Hey Prob and Stat students, today we're going to be doing 7-2 lesson day 2. I just want to reiterate and really try to drive home the concept or the differences between 7-1 and 7-2. 7-2, the only difference is that it's going to be sample standard deviation. That is what's going to make a problem a 7-2 problem and not a 7-1. And what I'm going to go ahead and say, most of the time, if it doesn't say what the standard deviation is, I would assume sample. So in 7-1, we had population standard deviation, and that's what this whole sigma known thing is. We had population standard deviation. The whole entire time, you're going to have sample mean, sample average, population average, true average. They're going to talk about all those words. That's okay. Every problem will have that. What you really need to start focusing on is the word sample standard deviation. So I really wanted to try to hit that, home so you guys can really start distinguishing between the two different problems. Okay, so today we're doing sigma's not known, which means we don't have population standard deviation. And the other big thing with today is we're going to be doing raw data, which means I'm going to be actually giving you all of the averages, all of the actual data values. So this is where you're the problems. I'm not going to give you x bar equals anymore. That's not going to happen. I'm going to give you all of the numbers. So let's say this is how many times you look at your phone during a class period. I'm going to be giving you all of these numbers, and then you're going to have to find the average, find the standard deviation. So let's go ahead and let's talk about what we're going to do. So here are the directions for the TI-84. You might want to pause the video and write these down. If you need any help with this, you can ask me in class on Monday. Oh, real fast. Use the X bar and the S, and make sure we are rounding to one more digit than the actual raw data. So make sure we're rounding to one more digit. All right, so here are the directions for my class calculators. It's the TI-30XS, and again, we want to use X bar and the SX. It's on the very first screen when you go through. So round to one more digit than the raw data. Okay, so here's the example. I want to make sure that you guys can actually see me type all of this into the calculator. So example 1, this is when we're given raw data. So we're actually given all of the values. So the data below represents a sample, which tells me right away I'm going to be using T alpha over 2, not Z alpha over 2. So the bottom represents a sample of the number of home fires started by candles for the past several years. Find the 99% confidence interval for the mean number of home fires started by candles each year. So right away, let's go through and let's write what N is equal to and what DF is equal to. N are the number of how many I have in the sample. So I have 1, 2, 3, 4, 5, 6, 7. I have 7 homes, which means my DF is going to be 6. So I can go ahead and find my T alpha. I can find my critical value by using my distribution chart. So please don't write on these. This is a bad example because it has writing on it. And I'm using 99%. So DF is equal to 6. So I'm going to do the 6th row, and 99% would be 3.707. So 3.707 is going to be what I'm actually going to be using for my critical value. Now I need to go find X bar and S, because think of my E formula. E is equal to T alpha over 2 times standard deviation, all divided by the square root of N. Well, I now have T alpha over 2, that's my critical value. So that would be 3.707. I don't know S, and I do know N, all divided by 7. The big mistake here is kids accidentally use degrees of freedom right there, so be very careful that you don't do that. Okay, now let's go ahead and let's find the average of all of these with directions that I listed before. Remember, these are your directions. We hit the data button, enter the data values in, press second stat, and then we're going to find out all of the good information from there. So let's go ahead and do that. So we're going to hit the data button, first turn it on. And if you want to press on and clear at the same time, it clears everything, even your lists. So let's go ahead and press the data button right there, and then enter in all the data values very carefully. So 5,460, and then you just press enter after you hit it, and then 5,900, enter, 6,090, enter, 6310. Okay, when you finish, see how that says L8? It's looking for the 8th value. That means you typed in 7, which is good. It matches our 7. All right, now what we're going to do is you're going to hit the second button, and then that data button, which is stat right above it. And then we have one variable, right? All of my numbers, there's one variable. So I'm going to hit enter, 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 keep hitting enter all the way until calc is flashing. And then we're going to hit enter one more time. Here are all of your goodies. Now this is a sample, so we need to use X bar, that represents a sample. And remember, we're using raw data, so we round one more than the original data value. Look at our original data value. There are no decimals, which means I'm going to need one more decimal place when I'm getting the actual answer. So I have 7,041. That goes right here, but I need one more decimal place than the original data value. So when I look to, I need that 4, but I need to know if I need to round up or round down. So I look to the 2. 2 makes me stay the same. S is right below it. Everything that you need is on that screen. So we have 1,610. 0.2, but we look to the 7 to round up or down. So that 7 makes that 2 round up to a 3. So there's all my data values. Now what I'm going to do is I'm going to plug in my S into the equation. So 1,610.3. I type all that in. You can press on and clear at the same time and it all goes away. And then I'm going to press that N over D button. So 3.707 times 161.3 divided by the square root of 7. Hit enter. This is E, so round to 3 decimal places. So that would be 214, and that 3 makes that 4 stay the same. So that would be 2,256.2. And now all I have to do is 7,041.4 minus 2,256.2 less than mu less than 7,401.4 plus 2,256.2. And when I do that, my final answer, let me go ahead and flip to the next page, right here. Good job. All right, guys. I hope this was a little bit easier actually being able to see my hand. Thanks for watching. Okay guys, looking at the screen now, I don't want you to get confused with this number. I'm not sure where this number came from. So I just want to let you know, don't worry about that number. It's this that goes here and this that goes here. So, all right, next slide. Okay guys, so here's your first U try. If you need to, if you don't have a calculator that can do mean and standard deviation, right away, then go ahead and find mean. You know how to find mean. You know, it's you add up all the numbers and divide by the total. That's what mean is. And then to find standard deviation, remember the formula is the square root of, so the standard deviation formula is the square root of n times the sum of all your x's squared. These are all your x's. So take each one of those and square them, and then add that up. That's what this number is going to be. And then multiply that by n. We've got 1, 2, 3, 4, 5, 6. So n would be 6 in this case. And then this one says take all of your x's and add them. So add them up before you square them. Add them and then take that sum and square it. Subtract those and then divide by 6 and then times 5. So that'd be divided by 30. This is going to give you sample standard deviation. Make sure each one of these we are rounding to one more decimal place. So see how there are 2 decimal places, that means these answers are going to have 3 decimal places. So round to the thousandths, not the tenths or the hundredths, but the thousandths, which means we're looking at the 4th number to determine what that 3rd one rounds up to or down to. All right, so go ahead and pause the video and try this problem. Either use a calculator if you have it, or go ahead and do the 2 formulas. Here are your answers. So here's our final interval. Our standard deviation was 3 decimal places. Our x bar was 3 decimal places. That's what I was just talking about. So we should have gotten E. Here's our E right here, 0.046, and then 0.046, and here's x bar. That's what we found. So we have x bar here also. And then your final interval gets rounded to whatever standard deviation is. And standard deviation was 3, which means this gets rounded to 3 also. So here's our final interval. One can be 98% confident that the population mean, or this can be called true mean, amount of nitrogen oxide emissions for all cars falls, that was really hard, within this interval. All right, let's start talking about this one, because this one's going to be tricky on the quiz. Choosing between Z and T. To do Z, this is our purple sheet. This is our new sheet, the new table. To do the purple sheet, sigma has to be known. We have to be given sigma. What's sigma? Sigma is the population standard deviation. So sigma has to be known. That's the very first most important thing. And then one of the other 2 things can happen. I'm going to write that in green. Either the variable is normally distributed, or it says that the graph is symmetric. So either the variable is normally distributed, or it says the graph is symmetric. That either needs to happen, or our sample size has to be 30 or above. It's an or between these 2. The red, this, or I'm going to do in blue, this has to happen. That has to happen. And then the following in green, it's either or. Or, so this, it's either symmetric or it's n is greater than or equal to 30. And that's, again, that's our sample size. So that's the first thing. If those happen, then we're going to use the purple sheet. Now let's talk about the Z, or the T sheet. And it's very simple. If you're given S, or sigma's not known. If sigma's not known and we're given S, then you get to use the new sheet, the new table. And those are going to be 4 decimals, or 4 numbers. So these numbers are 3. These are going to be 4 numbers. So make sure you're telling a difference between the 2. All right, let's go ahead and practice this on the next slide. So here's a you try 2. I'm going to do the first one for you. And the first one's extremely simple. You're given S. Right away you're given S. So you know this is a T problem. So go through the rest of them, and then go and find it. So actually find the T problem. And remember, you're going to need N, so we need degrees of freedom, and the percentage. We need to know how far. This is the row. That's what degrees of freedom is. That's how far down the paper we're going. And the 99% will tell us how far over we're going. All right, so for this one right here, that would be T. Go through and figure out if each one is 0, or I'm sorry, if it's either Z or T, or if it's neither of them, the answer is going to be neither. All right, so go ahead and pause the video and try those problems, please. All right, here's the you try. So for the very first one, we used T because S was given. So right away, those were together. And the second one, sigma was given. So we've got to check 2 things. Either our sample size is greater than 30, and that didn't happen, but we're not out of the water yet. Then go and look at the distribution. It's extremely skewed. If this would have said symmetric, then we would have been okay, but it doesn't say symmetric. So extremely skewed doesn't work either. So we can't use either of them. It's going to be a neither situation. All right, the one right below it, we're given sigma. So Z is automatically going to happen. T is no longer going to happen because we're given sigma. So once you're given this sigma, you're no longer going to use T. T is out of the question now. So it's whether or not we can do Z or neither. So check our 2 requirements. We need a sample size bigger than 30, or we need symmetric graphs. Well, we've got a sample size bigger than 30, so we're done. We're definitely going to be able to use Z. It's a purple paper, so you've got it memorized, which is 1.96. All right, last one, we've got 90%, or let's just go straight to standard deviation. We've got S, so automatically if I have S, you know it's going to be T. So it's very simple if you look at that standard deviation first. If it's population, you've got to check your requirements. If it's S, automatically T. So our degrees of freedom for this problem would have been 7, and then we would go over to the 90% column. All right, let's go on. All right, thanks so much for watching, guys. You already did this assignment. That's what we did the day before because I didn't have the video up. But thanks again for watching, and I hope you guys have a fantastic weekend.